Welcome friends, myself Ankon Bhattacharya, student of Physics Honours BSc, studying from Krishnath College, Barampur. Now, in this video, we will going to discuss about the nuclear physics. Nuclear physics. The properties of the nucleus and the physics behind the nucleus. Now we already know that what is nucleus. Nucleus is the core center of any atom of the matter. Now from class 9, class 10, class 11, class 12 we have learned many things about the nucleus, but the properties, why the properties are present there, we did not know. So in this lecture series, we are going to discuss in detail the nuclear physics. And you know that the branch of physics, the nuclear physics is the branch of physics which dealt mainly with the essence of the physics behind the nucleus. Here the mathematical treatment is very simple and quite relevant, but the physics is very important here. If you like the video, then you press the thumb button and subscribe the channel for more updates. Now, the nuclear physics, before going to discuss about the nuclear physics, I want to tell you some story. At the year of 1909, scientist Rutherford gave an assignment to his students, and his students were noticed and informed Rutherford that some non-describable events are occurring there. So Rutherford were present there. Rutherford was present there, and Rutherford came to them and observed that this is not established before this experiment. So this was the alpha ray scattering experiment. Now Rutherford performed himself the gold foiled experiment in the year of 1911, and scientists believe that from this the existence of nucleus was proved. So the nuclear physics was started from there. But this is not true. Many scientists believe that the nuclear physics was started at the year of 1896, when Becquerel was first able to observe the different nature of uranium. When he placed when Becquerel during his experiment on fluorescence of uranium, he was noticed that photographic plate were affected by the uranium salt in spite of being covered up by the platinum black paper. So to discuss about the different nature of this, radioactivity was evolved. Now what is radioactivity, we will discuss in later. Now before going to discuss about the nuclear physics, I want to tell some terminology relating to it. Now nuclear physics. At first we have to study the static and dynamic characteristics of nuclear physics. Now what is ground state energy, you know very well. What is ground state energy? Ground state energy is the energy level of the lowest energy level occupied by the nucleus, similar to the atomic physics. Like the atomic physics, nuclear, like the atom, nucleus may also present in different quantum state depending upon its energy. So the lowest possible energy is called ground state energy, in which the nucleus mainly belong to. When the nucleus belongs to the ground state energy, the properties associated with the nucleus is known as the static characteristics. Now under these static characteristics, different properties like nuclear size, nuclear shape, nuclear charge, etc. But there lies also the dynamic characteristic, when there is some energy difference between the different energy level of the nucleus. From dynamic characteristic, radioactivity was evolved, and the emission of alpha ray, beta ray, gamma ray. We will discuss in later these in detail. Now the representation of atom is very important. What is the representation process? If any atom be represented by X and its atomic number be Z, then Z should be there, and the mass number be A. In this way an atom can be represented, where A is the mass number and Z is the atomic number. What is atomic number? You know very well that atomic number is defined as the number of proton present in the atom. And what is the mass number? Number of proton present in a nucleus of any atom. And what is mass number? The sum of the number of proton and neutron present in a nucleus of an atom. Now the nucleus is composed of proton and neutron. At first proton was discovered, then neutron was discovered. In the discovery of neutron there lies a great important story, an interesting story. You will enjoy when you learn this story. So the component, there are two components of the nucleus which are known as a nucleon. So nucleons are the proton and the neutron, and from Heisenberg's uncertainty principle you know that the electrons cannot be associated within the nucleus due to the high energy. If the electron be present in the nucleus, then it should have energy many mega electron volt, 10 to 20 mega electron volt, whereas the electron emitted during the experiment from the nucleus is only 3 to 4 mega electron volt, and the binding energy of electron is some few electron volt. The orbital electron have the binding energy of the order of few electron volt, whereas the nucleons have the binding energy about a few mega electron volt. So these great difference between the energies, from the Heisenberg's uncertainty principle we know that the electrons cannot be associated within the nucleus. So the nuclear component are proton and neutron, which are collectively called the nucleon, and on the basis of the nucleon, when we study the characteristic of atom, then it is called the nuclide. So this was the basic terminologies relating to the nuclear physics. Now we know that the negatively charged electron move around the nucleus, and there lies a centripetal forces which is equivalent to the Coulombic interaction. So we know that the radius of the nucleus is of the order of 10 to the power minus 14, whereas the radius of an atom is angstrom order. In angstrom order, that is 10 to the power minus 10 meter. Now we define the mass number and atomic number. From this we can get the number of neutron as A minus of Z. So this is the neutron number. Now to explain the nuclear stability, one must thus assume that the nucleons are held by a very short range force. Now there you may ask me that protons are positively charged, and we know that the neutrons are neutral particle. So in a small space, many positively charged particles accumulated, so there should be the repulsion, a great repulsion between them. So there arises a question of nuclear stability. Why the nucleus is stable? It should not be stable because of the existence of highly positively charged particle, and from our knowledge of Coulombic interaction, these charged particle cannot associated within it. So I will answer that here lies a short range force. We know that there in the universe 4 types of forces are present: gravitational force, electromagnetic force, Coulombic force, and the short range force. The short range force is present within the nucleus, which is different from the electromagnetic force or Coulombic force, so that the nucleus is stable in spite of being present of highly positively charged particles accumulated within it. So From the knowledge of atomic number and mass number, a pair of atom may be isotope, may be isobar, may be isotone or mirror nuclei. What are these? First, isotope. Isotope. What is isotope? When a pair of atom have the same atomic number, that is same Z, from this we can say that these are same compound, same atom, same atoms, okay, or same elements, better to say same elements, same elements. Isotope at the isotope may be defined as the pair of atom having the same atomic number, that is same element but different mass number. Example: 12C6, 14C6. Here the atomic number is same but the mass number are different, so these form a pair of isotope. Now what is isobar? Just opposite to it, same mass number but different atomic number, that is it should have the different element. So what is isobar? A pair of atom whose mass number is same but the atomic numbers are different, it is known as the known as the isobar. What is the example of it? 14C6, 14C6 and 14C7 nitrogen. Here the mass number is same but the atomic numbers are different, so these form a pair of isobar. Now what is isotone? Isotone is very interesting. Here the difference between the mass number and atomic number is same. Now the difference between mass number and atomic number is what? Is called the neutron number. So the pair of atoms in which the number of neutrons are same is called the isotone. 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 If we take an example of isotone, then I will say that sodium 2311 and magnesium 1224. So here the difference between 23 and 11 is 12 and the difference between 24 and 12 is also 12. So the neutron number is same but the atomic number and mass number are different. So these form a pair of isotone. Now another term is there, which is mirror nuclei. What is mirror nuclei? Mirror nuclei. Okay. Mirror nuclei. Mirror nuclei. What is mirror nuclei? An isobaric pair of atoms. Isobaric pair of atoms means the mass number is same. So isobaric pair of atoms, if we take an example of this, isobaric pair of atoms whose mass number is same have the same number of an isobaric pair of atoms whose mass number are same and the number of proton and neutron are interchangeable. That is, here the number of neutron is 5 and here the number of neutron is 6, whereas here the number of proton is 6 and here the number of proton is 5. So the number of proton and neutron are interchangeable among them and they differ only by 1 unit. Is called the mirror nuclei. So these form a pair of mirror nuclei. Mirror nuclei is very important in both the examination purpose and both the knowledge. Now we will study the static characteristic of the nucleus. At first we will study the nuclear mass.
তা তো ঠিকই, হ্যাঁ হ্যাঁ হ্যাঁ, কোনো ক্লাস নেই। পজ করে দেখি।